This is Chiban Acharya. In this video, I will do the homework from section 3.2. The topic is measures of dispersion. And first question is compute the range and the sample standard deviation of strength of concrete in PSI. Here the data set is given our strength of concrete, okay, strength of concrete. Therefore some concrete has 3990 psi strength, other concrete has 4050 psi strength, and so on. This is the sample data. It says sample, okay. You got to find range and the sample standard deviation. Two things here, range and the sample standard deviation. Okay, to find the range, we find the largest data value minus smallest data value. Okay, what's the largest data value here? The largest data value here is 4050. The smallest data value is 2980. Okay, therefore you subtract these two numbers, 4050 minus 2980, and your answer is going to be 1070 as a range. Now to find the sample standard deviation, I'm gonna use a calculator, and that's the calculator. Always starts with start. To put the data in the calculator, press start, and number one, press number one, which is edit, and put the data in the calculator. Since my L1 L2 already have a data, I can put anywhere. Even I can put L3 or anywhere, doesn't matter. Let me put the data in L3, okay, and you know how to type that. 3990, first data, enter. Second data is 4050, enter, and I'll be back. Okay, I put the data in the calculator. When I pause the video, and I put all data in the calculator here, okay, in L3. Notice that the data are in L3. And now to find the standard deviation, I have to go to the start again, and I got to select calc by using this arrow button, and I had to select 1, which is 1 for stat. Select 1. Okay, now this blink here, and I have to tell the calculator that where is my data is. Since my data is in L3, I'm gonna type L3 here. To type L3, see L3 is here above 3. Therefore, to find the L3, you press second and 3. They give you L3, and press enter. You get the data, and you see the standard deviation here, S of x and sigma of x. This first one is sample standard deviation. The second one is population standard deviation. Since this is the sample data, therefore I'm looking for sample standard deviation S of x. But notice that we have just lowercase s here. That's fine, which is same as S of x. And this lowercase s is symbol to represent sample standard deviation. Okay, what's the answer? If you round it to 1 decimal places, remember that you round it to 1 decimal places here, and your answer is going to be 489. Okay, let's just say 489 as a sample standard deviation. Of course, range is 1070. Question number 2. If the variance of the variable is 16, what is the standard deviation? Notice that the 16 is the variance of the variable, and the question asks for what's standard deviation. And the formula is here. Variance is square of the standard deviation. I put SD for standard deviation. The variance is square of the standard deviation. Okay, in another word, or standard deviation is equal to square root of variance. Okay, variance. Then here variance is 16 and square root of 16 is 4. Therefore here 4 is standard deviation, which variance is 16, and you notice that square of 4 standard deviation is 16, which is variance. Question number 3. Here the question actually find the sample variance and the standard deviation. Sample variance and standard deviation also sample of this data set. Okay, first thing I have to do is I put this data in the calculator. To do that, I'm just gonna go to the calculator here, and I just start with start, and I just press number 1, which is edit. I can put anywhere. If I want to put in L1, let's go highlighted L1 by using this arrow button. Listen, okay, and you clear and enter. That means L1 is clear. Similarly, you can clear L2 and L3. Since L1 is clear, I can put the data in L1. And 6, I type 6, enter. I type 56, enter, and I'll type 12, enter. I'll pause the video, put all the data, and back to you. Okay, I put the data in L1, and what I'm going to do is to find the standard deviation. I have just to press stat again, and I had to highlight calc using this arrow button, and I press 1, which is 1 press stat. Since it's blinking here, my data is in L1. Either I can type L1, or by default the calculator takes data from L1. Okay, and I'm good. I have to do nothing. Press enter, and you'll see that the sample standard deviation is going to be 15.29124569. I'm writing all digit possible here. Sample standard deviation is going to be I should say S equals to sample S equals to 15.2912. I write a couple of digits after decimal because I'm squaring this to get the variance. Okay, but when you write the answer for standard deviation, that's the second box. Here you choose this lowercase s for standard deviation. Notice that this notation is for population standard deviation. This is called sigma. Okay, this is called sigma, population standard deviation. But we use sample standard deviation, therefore I use this s. And when you write the answer, when you round it to 1 decimal places, your sample standard deviation is going to be 15.3. Remember that 15.2912 gives you 15.3. But when you find the variance you have to square that. Then when you do s squared, that means 15.2912 square of that. Okay, let me square this. 15.2912 square of that is going to be 233.82. Since you're rounding to 2 decimal places, you write 233.82 as a variance. Therefore variance is going to be 233.82. Notice that you have to select s square here, not sigma square, because sigma square is population variance, but we're looking for sample variance. You have to pick s square for the variance here. Question number 4. The accompanying data represent the pulse rate, bits per minute, of 9 students enrolled in the statistics course. Okay, the data is pulse rate. This treat the 9 students as a population. Therefore, the question tells you that these 9 students here uh, this treat this as a population. In other words, this 9 data represent the population. Therefore, the question asks you, compute the population standard deviation. Look at the symbol here, that's the sigma for population standard deviation. Okay, that's sigma. And now the question is, how do you find it? Again, we use a calculator. I have to put the data in the calculator. Let's do start and number 1, which is edit. Since I have all the data L1, I can just clear that data by selecting L1, press clear and press enter. The data is gone. And now put the data in L1, and you have to put 70, 78. I'll be back after putting the data. Okay, since I put the data in the calculator under L1, to find the population standard deviation, all you have to do is start. You select calc using this right arrow and press 1, which is 1 with stat, and we put the data in L1. Therefore, by default, the calculator takes data from L1. You good. Just enter, and you see that this is the population standard deviation sigma x. But the question tells you round it to 1 decimal places as needed. 1 decimal going to be 8.2, and so sigma going to be 8.2, which is population standard deviation. Part B, determine the sample standard deviation. Notice that in the second part you have to find the sample standard deviation of the 4 and 3 samples of size 3. But notice that sample 1, sample 2, sample 3. You got to find the sample standard deviation of these 3 samples. Remember that Kathy, Megan, and Perpetual is the first sample, and you got to find the standard deviation of pulse rate of these 3 people: Kathy, Megan, and Perpetual. Let me see. Kathy here has a pulse rate 74. Kathy. Megan has a pulse rate 78, and Perpetual has a pulse rate 70. Okay. Now you got to find this sample standard deviation of three data set. As you did before, go to the calculator, press start. That's why we do every time, to put the data. Number 1, and I can put in L3, doesn't matter. 74, 78, and 70. Okay, now to find the standard deviation, here sample standard deviation, you go to the start and select calc using this right arrow button, and number 1, which is 1 for stats. Now you have to type L3 here because this data is in L3. For to find L3, you go to second and press 3. You get L3. Press enter. You get sample standard deviation, which is 4. Notice that this is the sample standard deviation, which is 4. Therefore, for sample A, the sample standard deviation is going to be 4. Similarly, you do for sample 2, Janet, Megan, and Crystal. For them, sample standard deviation is going to be 4.5. And for C, third part of this part B, sample standard deviation of Jeff, Kevin, and Clarice is going to be 5.2. Okay, but notice that population standard deviation is going to be 8.2. We have 3 sample standard deviation, and we can say that sample 1, remember that sample 1 has less standard deviation than population. Therefore, sample 1 underestimate the population standard deviation. Underestimate. And sample 2 also underestimate population standard deviation. And sample 3 also underestimate the population standard deviation. Also underestimate. Okay, that's the question number 4. Question number 5. Suppose that the customer is purchasing a car. He conducts the experiment in which he put 10 gallons of gas in the car and drives it until runs out of the gas. He conducts this experiment 15 times on each car and records the number of miles driven. Remember that there's 2 cars here, car number 1, car number 2, and he does the same thing for 15 times in both car 1, car 2. Okay, but this is the sample data. Notice that he choose, of course, 2 cars, and he did 15 times, and these are all other sample data. In the question number 5 is you got to find sample mean for car 1, sample mean for car 2, and median for car 1, median for car 2, range for car 1, range for car 2, sample standard deviation for car 1, sample standard deviation for car 2. Okay, I'm not going to finish this question because you know how to find all this mean and median and standard deviation using calculator. I taught you in previous problem, and you use again 1 bar stat option, this function, use a calculator, and you'll find sample mean for the first car going to be 249.7. sample mean for second car going to be 252.3. Pause the video and do yourself. You should get this number for car 1 and car 2. Median of car going to be 251. Median of car 2 going to be 257. Range of car 1 going to be 172. Range of car 2 going to be 92. Sample standard deviation of car 1 going to be 49.7. Sample standard deviation for car 2 going to be 25. Okay, again, all this numbers comes from the calculator. If you put the car 1 data and find all of this mean, median, standard deviation for car 1, and do the same thing for car 2. And let's answer the last question. Which car would the customer buy and why? Okay, and the answer is, listen, because car 2 has low standard deviation, car 2 has less dispersion. Okay, standard deviation is measure of dispersion. Since car 2 has low standard deviation, it has more predictable gas mileage. Therefore, the customer should buy car 2 because it has low standard deviation and more predictable gas mileage. Okay. Question number 6 is similar to question number 5. And question number 5 you did for car 1 and car 2. Question number 6 you do for city 1 and city 2. Okay, city A and city B. This is similar, therefore you can finish yourself. Alright, question number 7. Complete the following statement about the empirical rule. Notice that this is very important rules in this section. The empirical rule you might know from the PowerPoints or my lecture video. What's empirical rule about? I'm not going to do detail because I talk about the detail in the lecture video. According to the empirical rule, if a distribution is bell-shaped, and then approximately 68% of the data will lie within 1 standard deviation of the mean. Okay, approximately 95% of the data will lie within 2 standard deviation of the mean. Finally, approximately 99.7% of the data lies within 3 standard deviation of the mean. Therefore, that's the empirical rule. Okay, Question number 8. A small computing center has found that the number of jobs submitted per day to its computer has a distribution that is approximately bell-shaped. Okay, now since the distribution is bell-shaped, I just make the bell-shaped curve like this. And here on this line you have a data. Here the data is number of jobs. Okay, number of jobs gonna be here on this line, and this highest point corresponds to the mean, which is gonna be 91 jobs. See, mean job is 91 and the standard deviation is 11. Alright, if you add standard deviation 11 to the mean, you get 91 plus 11, which is going to be 1 or 2. 1 or 2 going to be here, and this is the one standard deviation above the mean. This point here is one standard deviation above the mean. If you add again 11, you get 113. This is 2 standard deviation above the mean, and if you add 11 again, you get 124. This point is 3 standard deviation above the mean. Similarly, if you subtract 11, you get 80, you get 69, you get 38. I'm sorry, 58, not 38. 58. Okay. Now this is the within 1 standard deviation from the mean. This is the 1 standard deviation. This area or this percentage here corresponds to 68%, because you know that 68% of the data lies within 1 standard deviation. But this, between 80 to 102, 68% data lies here. And then another word, this is going to be 34%, this is going to be 34%. And from here to here, 69 to 113, within 2 standard deviation. Notice that 91 to 113, 2 standard deviation above, 91 to 69, 2 standard deviation below. Therefore, between 69 to 113, there is 95% data lies within that 2 numbers. Therefore, between these 2 numbers, here, you have 95%. Okay. Now the question tells you, what would we expect approximately middle 95% of the distribution falls, and you see that between 69 to 113, approximately 95% of the distribution fall, or 90% of the data falls between these 2 numbers. Here, between 102 to 113, 13.5% falls here, and this is here also 13.5% falls here. Here, 2.35%. Here, 2.35%. Okay, and outside 3 standard deviation here, 0.15%. Here, 0.15%. Notice that this is the common for any bell-shaped distribution. If the distribution is approximately bell-shaped, we can use empirical rule. That's the standard for any bell-shaped distribution. Okay, this number 34% here, 13.5%, 13.5% here, 2.35%, 2.35% here, 0.15%, 0.15% here is standard. Okay, let's do question number 9. It is exactly similar to question number 8, because you can see that it is the distribution is bell-shaped. See here, if you read the question, it says distribution is bell-shaped. As long as distribution is bell-shaped, we just start making the bell-shaped curve like this here, and here is the mean. This is the mean, and here 1 standard deviation, 2 standard deviation above, 3 standard deviation above, 1 standard deviation below, 2 standard deviation below, 3 standard deviation below. And if you remember from the previous question, you put the percentage in each boxes here, and that's the mean, which is $125. That's the electric energy cost, and the standard deviation is 14, and next number is going to be 125 plus 14, which is going to be 139. Next going to be 153. Next going to be 167. Okay, if you go below mean, you have 125 minus 14, which is going to be 111, and 111 minus 14, which is going to be 97. 97 minus 14, which is going to be 83. Okay, that's the number which are what standard deviation above the mean. This is the 1 standard deviation above, 2 standard deviation above, and so on. This is 1 standard deviation below, this is 2 standard deviation below, and so on. Let's put the percentage down here. And as you remember from the previous problem, you have 34% lies in this box. Therefore, we put 34% here, 34% here, 34. You put 13.5% here, you put 13.5% here. Okay, and here you put 2.35%, here you put 2.35%, here you put 0.15%, here you put 0.15%. Again, this is the standard numbers in the empirical rule. Okay, let's answer the question. What percentage, here the question, what percentage of the home will have the monthly utility bill more than 111? 111 here. If more than 111 is pretty much this way, but you're adding this all percentage. Okay, you're adding 111 here, you're adding 34%, 34%, 13.5%, 2.35%, 0.15%. That is going to be approximately, if you add, you get 84%. Okay, if you add all the numbers, 34 plus 34 plus 13.5 plus 2.35 plus 0.15%, you get 84%. Therefore, approximately 84% home will have monthly bill more than $111. That means you add all the percentages that are above 111. Question number 10 is similar to question number 9. You make a chart and do the similar, and you'll get the answer. Okay, again, notice that it says bell-shaped, roughly bell-shaped, and use empirical rule. That's the empirical rule. As long as you put the percentage in the box and you make a bell-shaped curve, that is you using empirical rule, and you can finish number 10 yourself. Okay, number 11 is similar to number 12, and let's do number 12. Okay, the weight of organ in the adult male has bell-shaped distribution with the mean of 320 and standard deviation of 15 gram. Okay, the organ in adult male has a bell-shaped distribution. Therefore, we're going to make it bell-shaped curve with the label. Okay, what I'm going to do here is I'll just make a curve here. Let me put down here. This is all the weight here. All the weight going to be in this line, and the distribution is bell-shaped. You make a bell-shaped curve, and that's the mean. Okay, that's the mean, which is going to be 320. The mean is 320 here. Okay, now you got to label this point, this point, this point, and you label down this point, this point, and this point. Notice that this is 1 standard deviation above, 2 standard deviation above, 3 standard deviation above, 1 standard deviation below, and so on. Let's find this point. Since 320, if you add standard deviation 15, that means 15 plus 320 going to be 335. If you add 15 into 335, you get 350. You add 15 on 350, you get 365. So on, you subtract 15 on 320, you get 305, you got 290, this point, you got this point, 275. Okay, now let's make a box and put the number in its box to answer the question. That's the empirical rule for Bell-shaped distribution. Okay, you can excuse my boxes here. This is supposed to be equal size, but this looks bigger, but that's okay. You know what I mean, right? This 34% goes here, 34% goes here. That's how 34 plus 34 is 68% within one standard deviation. Okay, this goes 13.5%, this goes 13.5%, and this goes 2.35%, this goes 2.35%. all right, and this is 0.15%, this is 0.15%. now look at the question. Let's answer the question. About 95% of the organ will be between what weight? Look at 95% is within 2 standard deviation. Okay, this is 95%. 35.5, 13.5 plus 34 plus 34 plus 13.5. This is 95%. Therefore, 95% of the organ will be between 290 and 350 gram. 290 and 350 gram. In other words, there is 95% of the data that lies between 290 gram and 350 gram. Okay. Second question. What percentage of the organ weight between 305 and 335 gram? What is 305? 305 is here. 305 is here. And 335 is here. 305 and 335. How much percentage? Between 305 and 335, you can see that 34 plus 34. That means 68%. Don't type the percent, you'll have a percent here. What percentage of the organ weight between 305, less than 305 and more than 335? Less than 305. How much percent less than 305? What do you think? Less than 305 is this way. Less than 305 is this way. 305 is here, right? Less than 305 is this way. You're adding 13.5, 2.35 and 0.15. Okay, 13.5 plus 2.35 plus 0.15, and that is going to be 16%. Therefore, 16% of the data are less than 305. How about more than 335? More than 335. 335 is here. More than 335 is this way. Okay, more than 335. More than 335 is this way. Therefore, you're adding these three numbers to get how many percentage are more than 335. The same thing, 13.5 plus 2.35 plus 0.15, which is 16%. Therefore, final answer for this question is what percentage of the organ weight less than 305 or more than 335? Answer is 32%, because you add 16 and 16%, we get 32%. Okay, final question, what percentage of the organ weight between 275 here and 350 here? Okay, 275 with 350. Therefore, let me highlight here, you're using 275 and 350. 275 is here, 350 here. Then you're adding what percentage? Percentage in this box, in this box, in this box, in this box and this one in this box. Therefore you're adding 2.35, 13.5, 34, 34 and 13.5, you get 97.35. okay, these numbers 1 2 3 4 5 number add up to 97.35. That's the answer for part D. Question number 12 is finished. Complete the paragraph below. This is the fill in the blank question. The standard deviation is used to conjunction with the mean to numerically describe the distribution that are bell-shaped, and mean measure the center of the distribution, and the standard deviation measure spread of the distribution. Okay, that's the answer for question number 13. Question number 14. Which histogram depict higher standard deviation? Look at this histogram range. This range from what? 40 to 60. Okay, range pretty much 20 here, 60 minus 40, but here what's the range here? 70, I should say more than 70, like say 75 to 30, right? What's the range? 75 minus 30, which gives you 45. Therefore, since the histogram B has more range, it has more dispersion. You guys see that data is all over 30 to 75. Here data is between 40 to 60. It has less disperse, but it has more disperse. Histogram B has more disperse. Therefore, it has higher standard deviation because dispersion is more. The answer to this question is A. Histogram B depict the higher standard deviation because the distribution has more dispersion. You can see obviously how the data is spread here. Number 15. Determine if the statement is true or false. Variance is the square root of standard deviation. That's the false. Okay, variance is square of the standard deviation. Square of the standard deviation, not square root. Not root. Only what? Square of the standard deviation. Alright, number 15. Number 16. What makes the range less desirable than the standard deviation as the measure of dispersion? Range is less desirable than the standard deviation in the dispersion. Notice that range is dispersion, standard deviation is dispersion, but the range is less desirable than standard deviation because range does not use all observation. Okay, range use only smallest value and largest value, but standard deviation is all data value. Therefore, range is less desirable than standard deviation in the dispersion. Number 17. Compute the range. You know how to do that. Question number 18. Over the 10 years, 4 mutual funds all had the same mean rate of return 12. Okay, there is 4 mutual funds: mutual money, co-joint investment, together fund, and all for one fund. Okay, among these 4 funds, all has a same mean rate of return, but they have different standard deviation. Mutual money has 8% standard deviation. Co-joint investment has 6% standard deviation. Together fund has 4% standard deviation. All for one fund has 9% standard deviation. The question tells you which mutual fund investment is the most consistent for the rate of return. Most consistent. Therefore, that mutual fund which has less dispersion or less standard deviation is more consistent in rate of return. Therefore, the answer here is going to be together font because together font has only 4% standard deviation compared to other font which has more than 4% standard deviation. Okay, that's all about chapter 3 section 3.2 homework. Thanks for watching carefully. I should say carefully. I hope this helps you. Bye.